So now I'm going to show you guys OSPF on the CLI and show you what it looks like. So now we're on router 1 and I have loaded my OSPF configuration. Let me show you what it looks like. Show protocols OSPF, display it in set. So OSPF is pretty simple. I just created this configuration only. I said set OSPF within this area. This OSPF is hierarchical. It uses the concepts of areas. I will get into that in subsequent videos. So, but I'm saying my area is 0, and I'm going to put this interface in OSPF. Just like RIP was, right? We put an interface in RIP, right? So now I'm saying I'm putting this interface in OSPF area 0. I'm putting that interface in OSPF area 0. So I put both interfaces in OSPF area 0. Now I'm also putting the loopback address. So I don't have to do any export policy or whatever to export information, right? My direct routes. I just add the interface into it, and it's gonna export every route. It's gonna advertise every IP address that's on that interface to the OSPF network. So I added the loopback interface, and that's pretty much it. That's all. That's all for the OSPF configuration on router 1. I go to router 2 and we check it out. Show protocols OSPF, display set as well. And you can see router 2's configuration is quite easier actually. For router 2, I only have 2 interfaces I'm trying to advertise into OSPF, right? So I put that in OSPF. In Juniper, you just say set protocols OSPF area, whatever the area is, and put the interface you want to put in OSPF, and that's pretty much it. That's it. Now, router 1 and router 2 would form what they call an OSPF adjacency. And that's a whole nother topic in OSPF in a separate video. But just know that router 1 and router 2 form an adjacency relationship, and they start sharing routes, and communicating basically. But they form an adjacency, and they form an agreement, some understanding of the whole topology, because OSPF is a link state routing protocol. So it's gonna know about the link states of every node in that topology basically. So it's different from the distance vector routing protocol we discussed about RIP, which was just routing by rumor. It was just learning routes from another router and adding hops to that route basically. Okay, we've looked at router 1, router 2. I also configured P12 for redundancy, so I did the same thing. If you did show protocols OSPF on P1, that's the configuration. I put those 2 interfaces in OSPF. Pretty much it in Juniper. Now let's go to router 3. It's a Cisco device, and let's configure it for OSPF too as well. For router 3, it's pretty simple as well. I go into global configuration mode and I say router OSPF. I give it an identifier 1. Now I tell it what network I want to put OSPF on. Now there are different configurations. You can configure OSPF on the interface and put the interface specific configuration, trying to activate OSPF on that interface. You could do it that way, or you could do it as a network statement. And I want to show you the network statement way. So in OSPF configuration mode, I just say network, and I tell it the subnet, the address it should look out for. Any interface with an IP address within that subnet would have OSPF activated on it. So I go network 172.16.3.3, right? So I want to advertise all the loopback IPs that router 3 knows, but I want it to be specific. So I put a wildcard. Another concept that we'll talk about later on is called wildcard. I put in 0.0.0.0. That says match this IP address specifically. And I tell it what area 0. That's it. Now I do it multiple times for the other networks. So 3.33 and 3.133. Remember, use the up arrow to bring back a command from history. That's it. And I type the other network command, because remember, this interface is a 10.ip, right? This interface also 10.ip. So I need to also put a subnet, a matching wildcard, matching criteria to match IP addresses, interfaces that have that IP addresses, right? So I can put a network statement of 10.0.0.0, and I can say match the first octet only. That's what 0 does, is a wildcard. Match the first octet. Now I don't care about the rest. So when I want to say I don't care about the rest, I just say 255, 255, the 255. Oh, yep. So pretty much what this does is that this is saying match that octet, match the first octet, right? Any interface that has an IP address that starts with a 10 is going to have OSPF activated on it. Now the rest of the octets I don't care about, and that's what this is saying. And I put my area 0. That's pretty much it. And that's pretty much it. Now you can see what happened. We got a syslog message. So what happened? It says OSPF adjacency change. It says from loading to full. It saw it from 2 different neighbors. This neighbor on this interface, Gigi 10, and another neighbor on Gigi 20. Look, see what just happened. We didn't see this on RIP, right? Now in OSPF, on the Cisco router, it's forming neighbor adjacencies. Now, this Cisco router just formed a neighbor adjacency with this Juniper router. Isn't that awesome? Now, if we did show IP OSPF neighbor, I want to see my OSPF neighbor. Enter. What do you get? We can see that router 3 has 2 neighbors and they're all in full state, right? We'll get into that later on, but basically it has 2 neighbors on these 2 interfaces. So it has a neighbor relationship with these 2 Juniper routers. And now when we check the router table on the Cisco router, show IP route, check the routing table for OSPF. I want to see every route learned from OSPF. That's what this command is saying. Enter. Do you see this designation O? Remember when we looked at the RIP, right? We saw a designation of R, right? So basically for OSPF, you see designation of O. And if we go to the key table, O means OSPF, right? Basically, this router has learned OSPF routes. That's what it's saying. And do you recognize these routes? These are the routes that reside on router 1. It has been dynamically learned from OSPF on 2 interfaces. Now, router 3 has knowledge of those routes from 2 interfaces. So it has, you can see these 2 next hops. They're equal cost paths, right? Equal cost paths. Basically, router 3 has learned of the same route from this router 2 and P1. And that's why you have 2 paths for each network. It's there. It has the knowledge. Now, the difference between this is a link state routing protocol, is that every node in that topology knows about the link states of each route of every node in that topology. Basically, what am I saying? If I did show IP OSPF database on a Cisco router, it will show you routes learned from the link state database. Basically, now this is showing you the link state database routes. As you can see, it tells you OSPF router with this ID. So it's looking at this node in this database, and it's telling you about what this node knows about. This node knows about all these other nodes in the topology, basically. So it gives you link state, and this exact information is going to be similar in every other node in the topology. So if I logged into router 1, it's going to see the view of its own topology and also know the view of every other node's topology. That's why it's link state. They share link state of all the nodes topology and all their links, basically. So now router 3 has knowledge of router 1, 2, and 3. Let's go to router 1 and see what it looks like. On router 1, which is a Juniper router, if I do a show version, it shows you this is a Juniper router. This is a VMX on 14R version. And basically, if I did a show OSPF neighbor on Juniper, this is the output. It's quite similar to Cisco, right? It tells you, I know of these neighbors. I formed an OSPF adjacency with these neighbors, and they're in full state as well. And these are my neighbor addresses. Isn't this awesome? This is just like Cisco, right? This is Juniper's way of seeing the OSPF neighbor relationship from router 1. It has formed a relationship with P1 and router 2. if we compare this with the output from the Cisco device, right here, show OSPF neighbor. This is it. It's pretty similar, right? Yep, pretty similar. Two different vendors. Cool, right? Okay, cool. So now router 1, let's check his routing table. Show me your routing table. Show me any protocol. Show me any route learned from OSPF. Enter. And now router 1 has learned these routes from OSPF. And you can see it knows about the 172 addresses. It learned them. And it learned them from 2 different paths as well. It learned them from router 2 and it learned them from P1. But it chose the path to router 2. It chose that path. You can see that, right? Because they're like equal cost path. That's why they're both in they made it to the routing table. It's doing ECNP. Now, router 1 has knowledge of router 3's loopbacks. Router 3 has knowledge of router 1's loopbacks using OSPF. We can check the OSPF database as well, just like we did on Cisco. Show OSPF database. And this is the OSPF database that router 1 sees. See, it knows about the link state of every router in the topology. It even knows of the link state of a Cisco router, right? Isn't that awesome? See, this is a Cisco router. So basically every node knows about the link state of every other node. Link state routing protocol. That's pretty cool, right? Now, from router 1, we can ping, just like we did with static routing and RIP, we can ping router 3, router 3's loopback, and let's try that right now. 172.16.3.3, and let's source that from our own loopback, 192.168.1.111. Enter, and it's successful. We've been able to advertise reachability to our networks. We've been able to route between networks using OSPF. And you can see you have an idea of the differences, right? RIP was sending updates every 30 seconds. RIP on Cisco couldn't really form an adjacency, right? OSPF, on the other hand, on both the Juniper and the Cisco, they could both form neighbor adjacencies. You know, you could look at the link state of every node, right? It builds a topology, right? Information, you know. So it's like it's pretty intensive, pretty enhanced, really. Many other advantages. If we did show IP protocol on the Cisco device, it will tell us what IP protocols are currently running, right, on that device. And on Cisco, it shows you routing protocol running is OSPF. It tells you the router's router ID. Isn't that cool? Isn't that pretty cool? That's pretty cool. Cool. And it tells you the admin distance also. Cool. So yeah, that's a look on OSPF. Let's go on to our next routing protocol, which is ISIS. Let me show you ISIS and how it's also a link state routing protocol as well.